All right, college algebra. So these are the notes we took over 1-6. So I'm going to annotate here on the side and kind of explain the steps as I go. The first part, you're solving rational equations. So that means you're going to have rational expressions as your terms. Now notice the first thing I've done when I've written it down is I spaced the terms out. And so I had the students come up with a least common denominator. So that's what they wrote down here. So if I multiply the two denominators together, I'll get 2 times x plus 1. That's my common denominator. I also need to state that x can't equal -1 because right here, I can't have a -1 for x, otherwise I would divide by 0. What I had the students do next was insert that common denominator. So I'm going to multiply every term by the common denominator. So I'm going to multiply it by 2x plus 1. I'm going to multiply this one by 2x plus 1. And I'm going to do that here as well. Now when I do that, I have a 2 in the numerator and a 2 in the denominator, so they cancel out. I have an x plus 1 in the denominator and an x plus 1 in the numerator, so they cancel out. From there, I have this. And so on. So now you can come back over here to the notes we took in class, and you can see from here to here we FOILed, and we distributed, we collected terms together, and we solved for x, and we got 3/7. The thing you want to watch out for is that you want to make sure that you don't get a -1 for your answer. If you do, then you would have to say no solution. For example 2, you can see that x minus 5 is your common denominator. It shows up here and here, and so I wrote that down. And then that tells me that x can't be equal to 5. So I need to watch out. If I get 5 for an answer, I'm going to have to say no solution. We multiplied every term by x minus 5. That's in green. We canceled out where we could, top, bottom. And then we worked with what was left, and lo and behold, we solved for x and we got 5. But I can't circle that as an answer because x can't be 5. If it were, I would be dividing by 0. So we say the words no solution, or, oops, let me use a pen, not a highlighter there. Or you can state the empty set, which is just the brackets with the empty set symbol. On number 3, the problem had denominators of x minus 3, x, and x squared minus 3x. And we determined that x squared minus 3x is the common denominator. It happens to be the product of these two denominators. So if you go back and you think, okay, if I'm adding a third to 3/4, my common denominator is going to be 12. If I add a third to 3/4 to 11/12, my common denominator is still 12. 3 times 4 is 12. So that's the same thing I'm looking at over here. X minus 3 times x is x squared minus 3x. So I multiplied every term by that, and then I reduced where I could. I canceled out common terms, got it down to a quadratic, and from there I went over here and I factored. Got 2 for an answer. 2 is not 0 or 3, which is what x cannot be, because that's where we would be right here dividing by 0. So 2 is our answer. The students did number 4 on their own. I worked it out afterwards with them. Again, x plus 5 times x minus 5 is x squared minus 25. So this one times this one gives me this one. So therefore, x squared minus 25, or what it is in factored form, is my least common denominator. From that, I can gather that x can't equal 5 or -5. So we multiplied by the common denominator on every term. We canceled again. We took what was left, distributed, cleaned it up, and got plus or minus 5. But you can't have that for answers because if you did, you would be dividing by 0. So the empty set is your solution. Then we moved into part B, and these are radical equations. So I had them write it this way. The radical is over the 4x and the 12. And basically you want to move the radical to one side. You can square sides of an equation. You can't square individual pieces. So what I showed your classmates was you cannot do this. You cannot square this, and square this to remove the radical. That is illegal. So if you put the radical on one side, that allows you to square both sides of the equation. So I went from there to here, and then I went up here and I brought everything to one side and factored. Once I set my solutions equal to 0, I have to check them. When I check them, right here, I highlighted in the problem in yellow. Now I'll highlight it in blue so it's green. You plug your x values in the original problem for x, and then you're checking to see if it's true or false. Only the 6 makes it true, so I circle that one. On number 6, you need to take one radical and put it to the other side. The idea is to keep the radicals balanced, so you have one on each side. You FOIL sides of the problem, so this piece right here that I'm going to highlight in blue, that has to be FOILed. So we FOILed that out. We collected like terms, and then we squared both sides again. And when we square the right, we get 4 times x plus 4. Brought everything to one side, factored, checked our answers again, only 5 checks. We started with number 7 today. So on the second day, we started with number 7. And we cubed both sides after we took this term to the other side. And that removes the cube root. And so then we factored and solved. With a cube root, you don't have to check them. You won't get any extraneous solutions. Okay. And then we went into part C. X to the 3/2 equals 216. And we want to undo that power. So as you can see from my work, I raised it to its reciprocal power, which is a 2/3. When I multiply these together, I get 1. So that's why we use the reciprocal. If I enter 216 to the 2/3 in my calculator, I will get 36 as an answer. So this is the work on how you put it into your calculator. If you don't have a caret key, you might have a y to the x key. When we did example 9, it's the same kind of problem. We use the reciprocal power 5/2, but because the index is 2, that's the equivalent of taking a square root. So I've inserted here that you need a plus or a minus. So you only have to add the plus or minus when your index is even, and that's the denominator of that new exponent. And you've got some examples there. We have this part here where you have equations in quadratic form. You have the book's way, which is use substitution, and you have just factoring. If you're looking at the green, they set u equal to x squared and made a substitution in the problem. So they took out x squared and in its place they put u. And then they went through and factored. I did factoring by grouping. And then we solved each one for u, each factor for u from here to here. And then we know u is x squared because we said so right here. and then we took the square root and we took care of those and got 4 answers. If you do factoring, we did bottoms up this time. And so we went from here, oops, let me redo that boundary. We went from here to here, okay? And then we got to talking in class about how to clean up the square root of 1/12. I know that showed up in the practice problems from 1-4 in one of the answers. And a lot of students missed how to clean that up. So I just included that in today's notes. And that's the end. Please reach out if you have any questions.